So the guide number is a number that's usually on flash marketing materials or even on a review for flashes, for example. And all it really means is the guide number is equal to the distance times the F number. Now, this may not make a lot of sense, but so in order for it to make a bit of sense, we have to realize something about flashes. So when you take a flash picture, it happens very, very quickly. Very, 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 very quickly. So it happens, we can see the flash, but it really happens faster than we would be able to react to it. It's maybe thousandths of a second long that this flash is releasing this amount of light. And if you remember, we have this shutter that moves over the focal plane. And if you remember those high-speed videos of the shutter, what we saw in almost all of the cases was that so there's basically two curtains to the shutters. They're called curtains. And as one curtain was going up, the other curtain is following it shortly behind. This introduces this problem where at any one moment in time, only a small portion of the actual sensor is exposed. So if you are taking a flash photo and your flash fires at the exact moment that this particular portion of the sensor is exposed sort of to light, then the end result of that photo is that you're only going to see this little sliver properly exposed and nothing else is going to be properly exposed within that image, because the flash lasted for an instant, just this tiny instant that the shutter was open, and all the rest of that shutter was blocked for that particular shutter speed. Now there is actually a certain speed at which the shutter is open completely, and this is the speed that we can take flash photos, because any faster than that, we are going to have this problem right here where a portion of the sensor is masked by the shutter, so we are not actually going to properly expose all of the frame because it is being blocked. But there is a certain speed where one curtain opens completely, exposing the shutter, and a brief amount of time exists when the other curtain will close in front of it. So let's see, just to make this hopefully a little bit more concrete, I just want to show you those really cool videos from before, and hopefully I still have them here. Let's see, all right. Here's a good one. We'll look at this one. This is a film-based camera, a Canon Elan, but that's okay. It still is the same sort of idea. So here you'll see that when the shutter button is pressed, you're going to see one shutter curtain moving down and the other shutter curtain is moving up, or rather the other shutter curtain is following it very, very quickly thereafter. So I'm just going to go through it frame by frame. You can see here we have two curtains, this one down here, this one up here, and only this small sliver of the scene is actually exposed to the sensor. So if you take a flash photo and the flash fires right here, all you're going to see is that particular portion of the image that is properly exposed. Everything else is going to be black because it did not properly expose that particular part of the image. So what we need then, again, just as a reminder, is that this first curtain that falls, it must open all the way. It must open completely. Then there must be a little bit of time for the flash to fire while both curtains are completely open. Then the other curtain can follow and shut behind it. And this is called the sync speed of the camera. And this is relevant to SLRs because SLRs have physical shutters that actually move, as you've just seen a second ago. And many compact cameras don't actually have this restriction because they use electronic shutters. They just use electronic timing basically to figure out, okay, I should take a picture at this exact moment, and the entire frame is still visible. So you usually don't have this sort of problem that exists in compact flashes as well. But keeping this in mind, that there's a maximum speed, and for many cameras, it's about 1/250th of a second or sometimes as fast as 1/500th of a second, where once you set the camera to that speed, the first curtain will open completely, so completely exposing the sensor, and then the second curtain will follow behind it. That's the maximum shutter speed that you can take a flash photo without improperly exposing it. Okay, now with that in mind, we can look at this guide number and hopefully it will make a little bit more sense, because when we look at this guide number, you realize that there's no indication of shutter speed within it, because it's assuming that shutter speed doesn't really matter in this case. When we're talking about flash, the flash fires a certain amount of light, and if that shutter is open completely to capture all of that light, it doesn't matter how fast or how slow the shutter is, it's still only getting that much light from the flash. So for that reason, shutter speed is not that important, so it's really the F number that is important for us when we are talking about the guide number. Yes?
So does that mean that if you want to use a flash, that you put it on aperture priority and just let the camera determine it? Or how does that affect, like if you're shooting in manual mode, that means you still adjust the shutter speed?
Okay, so very good question. So when we're talking about these manual modes that I referenced earlier, yeah, so if you use the manual mode, for example, what you will generally do when taking a flash photo is set it at the sync speed. So at 1/250th of a second, that's the value for my camera. Your camera might be different. It's usually 1/250th to 1/500th. You'll set it to that, and then you will change the ISO and the F number accordingly, because those two other values still have relevance. So if you increase the ISO, it's now a little bit more sensitive. So if you have a certain intensity of flash, you can increase the ISO and that flash will now reach a little bit farther. Or if you are using a flash at ISO 100 and you know that, let's say at f4, for example, it can illuminate up to maybe 10 feet away, and now hopefully you can see where this guide number is coming in. So at ISO 100 and at the sync speed, I can use f4 at a distance of about 10 feet away. Now I can actually lower the F number, for example, to maybe 2.8 and be able to get a little bit more reach that way, because it's letting in more light that was available from the flash. Okay, but I know this stuff is really, really interesting, but let's take a quick 5-minute break. When we come back, we'll keep talking about flash photography. Hello, everyone. Welcome back. So before the break, we were talking about guide number and how it looks, I mean, luckily it's just, multiplying two numbers, so it doesn't look all that scary, but how there's a lot of information behind this number. So do feel free to stop me and ask me any questions that may come up about this stuff. But realize that all we are talking about at this point is that a couple of things are happening. Flashes, they fire the light that they have saved up in them very quickly, and the shutter actually takes a certain amount of time to travel over the sensor. And so for us to properly take a well-exposed flash photograph, we generally need to be using what's called the sync speed, or the X sync speed, depending on the camera manufacturer, which just means that there is a specific moment in time at which both curtains of the shutter are completely open, exposing the entire sensor. So if we assume that for at least the next couple of minutes of discussion that we are taking photos at the X sync speed, or, I mean, it could even be slower. It doesn't really matter, because you're not going to be getting any additional light from the flash if you have a slower shutter speed. Hopefully that makes sense, because if it's completely dark in this room, for example, I fire the flash, that's all the light you're going to get. It doesn't matter if you have your shutter open for hours, you're just not going to get any more light from this flash unless you fire it again. So for flash photography, most of the time, we can take a photo at the X sync speed. And this means that we can usually use the guide number as a rough estimate of how powerful this flash is, or how far we can expect the flash to reach an object and properly expose it at a certain ISO and at a certain F number, at that sync speed. So taking the sync speed out of the equation, we now realize that the guide number tells us quite a bit about the power of the flash itself. So usually what you see is a guide number at a specific ISO. Most of the time you see it, like you'll see a guide number of maybe 40 and it'll say at ISO 100 or something like that. And that's all it means, is that, you know, at an ISO of 100, you can get a certain distance times a certain F number. So let's say we have this guide number of 40. So what we would then be able to do is figure out, okay, I'm taking a photograph at the sync speed at ISO 100. That means that I can properly expose a photograph at f4 about 10 feet away. So assuming that the guide number is in feet, then that is what it is telling us. Sometimes the guide number is in meters, and if you're not comfortable with meters, you'll have to do a reverse conversion. But sometimes they even provide both for you. But anyway, by using an F number of about 4 at ISO 100 and at the X sync speed, you can properly expose a photograph at about 10 feet away. So let's say now that instead we change the F number 2 stops. Let's make it 2 stops brighter to F2. Remember, F2.8 is the intermediate stop between 2 and 4. So we are now using an F number of 2 at a guide number of 40 and ISO 100. How far can we take a flash photo? 20 feet. Yep, that's right. So 2 times 20 is 40. And so you can see that in order for us to double the reach of this flash, we actually have to let in 4 times as much light. Remember that inverse square law? So we had to go not 1 stop, but 2 stops away in F number in order to get double the distance allowed from the light. And that is because of this inverse square law. Yes?
How does that relate to the X sync speed?
So the X sync speed, we're sort of ignoring that because that is the maximum speed at which your camera can take a flash photo and properly expose the entire frame. If you take a flash photo any faster than that, you're going to get like a little band, a dark band, whose severity depends on how much over the sync speed you attempted to set the camera. So for most flash photographs, we're talking about taking photos at this X sync speed. Okay, so now let's say that we actually change this guide number to be talking about this same number at ISO 200. So now even though we are twice as sensitive, we don't actually get as much, we don't get basically a doubling of that guide number, because if you remember, you were doubling the distance from that camera, you were going to make the amount of the intensity of the light 1/4 available to you. So if we just double the sensitivity, that's not enough for us to actually increase the guide number by 2. It's actually going to be very similar to this F number. It's actually going to go up in 1.4 increments. So if you did some math, you would realize that at ISO 200, the same guide number, whereas before it was 10 feet at f4, we can now do only 14 feet at f4. Okay, so modern flashes, though, are very, very quick. They last from maybe 1/1000th to a second to even faster, to about 1/32,000th of a second. And so this is really, really fast, and you can use them actually in addition to stop quite a bit of motion. And in fact, that's what one flash pioneer, Dr. Edgerton, who was he took some wonderful photos using high-speed flash photography, and what he actually did was not use a very, very, very fast shutter speed to try to get this photo, but he instead used a very fast burst of light. And so this may sound counterintuitive at first, but you can actually use a very long shutter speed to take a photo just like this. So if you have a completely dark room, for example, there's no light, you have a very long shutter speed so that the shutter is open and accepting light, but there's no light for it to record. When you fire a flash that's very, very quick, maybe 1/64,000th or 1/32,000th of a second, you can properly expose something that happens very, very quickly in time while using a long shutter speed. And in fact, that is what Dr. Edgerton did in order to get photos just like this. So, and I realize that it sounds somewhat counterintuitive, but if you think about it, in terms of the amount of light that's available in the room, if you keep a very long shutter speed and there's no light available in the room, you're not going to see anything. You're not going to get any motion blur. You're not going to see anything until you fire the flash. Because when you fire the flash, that's when you get that short burst of light, and that's when you illuminate the object, essentially freezing it in time, and you are able to capture it on your camera. And in fact, this sort of thing is very possible for you to do at home with camera equipment, even just like this, frankly. So just an SLR camera where you can have a somewhat long shutter speed, a room that you can make very, very dark, and an external flash that you can try to fire remotely. You can usually find, whether for free or maybe for just a couple of dollars, basically instructions where you can design a circuit that uses sound to try to fire a flash. So you can adjust this circuit so that it will either fire very shortly after the sound or a slight delay after that sound occurs, so that you can use that, for example, in a very dark room to pop a balloon. This circuit hears that sound and it fires the flash, and then you're able to capture the balloon popping on your camera. And so this is actually a really fun way of being able to capture very high speed effects that can occur very, very quickly, very, very fast, beyond even the shutter speed of your own camera. And in fact, you can use the same sort of technique for taking shots of lightning, for example. So lightning, particularly at night, it happens somewhat randomly, and you may look at a photo and say, how on earth did they time getting this photo with that piece of lightning, or with that, that bolt of lightning that's occurring on the corner of the frame? And frankly, it's a bit of patience and it's a bit of luck. They were using a long exposure, like a bulb mode, for example, and they just waited for lightning to occur, because not much light is entering into their camera until that lightning bolt strikes. Then they can close the shutter and they can see that they have gotten that one lightning bolt within their particular image. But anyway, so going back to flash units, when we're talking about flashes, even consumer flashes that we can buy for relative inexpensiveness, so maybe a couple of $100s, for example, to buy a pretty decent flash unit, you can adjust not only their intensity, but this also adjusts their speed as well, because they can fire a certain amount of light in, let's say, 1/1000th of a second, and if you have that time, then you are also having the intensity, because that is as much photons as it can give out. So you can think of it as almost being a shutter speed for the flash, for example, in that it can only give off a certain amount of photons in a certain amount of time. So if you expel as many photons as you possibly can in 1/1000th of a second, and you have that, so now you have 1/2000th of a second, it's now twice as fast, you're also having the number of photons that this one flash can put out. So you can keep going, and usually they have a wide range. And so I mentioned before that flash units can go from about 1/1000th of a second to about 1/32,000th of a second. That's about 8 stops of light, because you go from 1/1000th to 2004, 8, 16, okay, I guess 6 stops. But anyway, the point remains that you have some number of stops of difference, and the less intensity that you have this flash give out, then you can have it give quite a bit faster flash time and be able to freeze more motion. Now, this is all the stuff behind flash, and hopefully now, understanding this, you can try to avoid photos that looks like this. So whereas before I was very embarrassed to show you that one photo where I had completely underexposed the bridge and completely overexposed the sky, now I have to further embarrass myself and show you a photo that I took of my siblings. Luckily, this was many years ago, 7 years ago, but this is a very difficult situation at the same time. So it's dark outside, and that's actually the moon, that's not the sun, by the way, so there's not a lot of light, and you're trying to take a flash photo and you're trying to get everything into the photo, but this photo really tells me, or should really show you, all of the things that I think can be wrong with flash photography. So let us count the ways. Okay, first of all, my brother and sister look more like demons than they already are because of their red eyes. Then, of course, we have only they are properly exposed. You can see it's very quickly, the light fall off is very quick. We can't see any of the white sand that exists behind them, which is very beautiful. Then, of course, we have the harsh shadows that exist directly behind them. They're not as obvious, but it is just as obnoxious. And on top of all that, the flash didn't even do its job. We still have motion blur, not only within them, but also in the background itself. So there's a lot of stuff, that's wrong with this particular photo. And to fix each of these things, there's different ways that we can fix each of these different problems that I just mentioned. So the red eye, for example, and many of you are probably familiar with why this happens, but we have the iris that light enters through, and if it's a big bright flash of light, our iris because we have adjusted to night vision, basically our eyes look very, very large. So all of the light is reflecting, going through the iris, reflecting off the back of the eye and just coming back out. And the back of our eye is actually red in color, and so that's why it looks red, here, in that the flash is just reflecting directly off the back of the eye, and it looks bad. It reflects off the retina and it looks bad and red. So is there a way that we can fix this? Well, many cameras have this really gimmicky red eye reduction feature. Sometimes it works, sometimes it doesn't. It depends not only on the camera's red eye reduction feature, but also the person you're taking a photo of. Younger folks, so for example, my brother and sister, children especially, their eyes can react very, very quickly to light. So red eye reduction features might work on them, but as we age, our eyes react more slowly. So it could take longer for the iris to actually, for the aperture within our eye to actually contract and try to change the size of the iris that exists here in the eye. So using red eye reduction is really, it's hit or miss, frankly. And so there must be another way that we can solve this. And one way is that if you realize that one of the reasons that we have this problem in the first place is that light is entering in and bouncing straight off the back, it's that these flashes are too level with the entrance of the light. So they are too close to where the light is also going to be entering in. So it's not a big angle here, so it's very easy for light to just reflect back into the lens. So one way that hopefully is more obvious now because of these context clues is that you can move the light up. You can move it up or to the right or just in some direction, and as you move it up, one of the things that's going to happen is that light is going to reflect differently. So if the light is coming from all the way up here and is coming down like this, it may reflect back, but it's not going to reflect back into our lens. So this is one of the ways that we can really do this, that we can really eliminate red eye, is by using what's called a flash bracket, or by holding the lens off of the camera, or rather the flash off of the camera, and trying to get some elevation to it, trying to make it so that it doesn't look, so that the light doesn't reflect directly off of the back of the retina. So there's a variety of ways, and many of them are really variations of just moving the light elsewhere, moving it away from the built-in flash that exists here. And so you could try some other tricks as well, like blinding your subjects temporarily with some very, very bright light, something like that. Or what might also work is not having them look directly into the camera. So in this picture, they're looking directly at me, and this is going to be a problem. I mean, yes, I can move the flash off camera, but if that is not available to me, another option I have is to recompose them, move them somewhere so that they're not actually looking at the camera. And not only would I possibly get a more interesting shot, but I will also eliminate this red eye. Okay, so the next problem is this harsh light. So I mentioned that we have these very harsh shadows that exist directly behind them. And this also can be corrected by moving the flash off of the camera. So if you have the flash that's right up top and you try to move it some number of inches away, this also has the side benefit not only of reducing the amount of red eye that you will get, but also changing the way the shadows are reacting, or the way that the shadows are presenting themselves within your photo. So if you imagine that you are letting off a certain amount of light directly in front of or directly on top of the lens, as that light hits the person, that shadow is going to happen, very quickly after them. But if you lift the light source up above the person, then what happens is that the light is coming down this way, and the shadows basically move under the frame. They move behind, let's see, it's hard to explain this in sort of 3D terms, but if I'm standing here, they don't happen sort of right behind me. They're perhaps more to the floor, if that makes sense, because the light is coming from here rather than from over here. So now all of this light is down here and hopefully away from the image that I am taking right here immediately. So now, so now I can eliminate those also by moving the flash off of the camera. And unfortunately, while with red eye you can use other methods to try to reduce it, through a variety of tips and tricks by moving the person, etc. This is a much harder thing to try to combat. If there's not a lot of light behind them, if they're not sufficiently lit behind, it's just going to be very, very difficult for you to try to combat this harsh light, these harsh shadows anyway. Okay, so I even mentioned that there was yet another problem with this image as well, and that was that this flash did not even do what it was supposed to do, and that is stop the motion. So they are still blurry, the background is still blurry, so what happened here? So rather than this camera using the fast shutter speed, that sync speed that I mentioned before, which is about 1/250th of a second, though at the time this was a compact digital camera that I took this photo with, it used a much slower shutter speed. So this could be using that night portrait mode, for example. So it thought, okay, well, I'm going to, with night portrait, I might take a flash photo so that I can expose the subjects properly. And then also I will have a long shutter speed to try to capture the light that exists in the background. And this is very, very difficult to do, no matter how you slice it, even if you have a tripod. So in this case, I didn't have a tripod. I was hand holding it. So with a slow shutter speed and a flash that was right near the lens, you can see why I got the exact result that I did. Not that this would really be an interesting photo to everyone else, just because it's my brother and sister standing in some sand. I mean, what can I say? But anyway, so even if I had a tripod and I set it up and I took the time to make sure, I set the mirror lock up and I made sure that it was absolutely positively still, and I took this photo and it fires the flash and it has a long shutter speed, no matter how still my brother and sister are, especially since they are, 2002, so they were probably about 5 and 6 at the time, they're still going to be fidgeting a little bit like, can I move now? And so you will still get a little bit of light that makes them soft as well. So it's very difficult to get a flash photo at night where you get the subjects absolutely still, even though flash can be used to sort of to stop motion, as we mentioned, because there's this other light that exists. You will still see this movement that exists. So the only time that you can really stop motion is if it's absolutely dark. Yes?
The other slide that you had where a bullet went through the object? So
Went through the
that
object.
motion was desirable, right? Right there.
So here, this really is meant to stop motion. And considering that this is a bullet flying through an apple, I think Dr. Edgerton actually did a pretty good job. But the reason that we don't see any motion blur is that there was no other light that existed in this room. It was completely dark. So only the flash was used to illuminate a certain moment in time, and that is what was recorded on film. If there was even so much as a little bit of light and there was a long shutter speed, then we would probably see a bit of motion blur, but also, with an emphasis on this exact moment in time, if that makes sense, because we have a little bit of light that's reflecting off of all of these things while the apple was still intact and while the bullet was still firing. But because we've made the room completely dark and fired the flash at this exact moment, we now have only captured that one moment in time, no other moments.
Shutter speed high here or low?
The shutter speed is probably pretty low here. I don't know what it actually is, but it could be on the order of minutes, frankly. Just because if there's no other light, it doesn't matter how long the shutter speed is, it's only going to capture the light that's given off by the flash here. So it's only even if it's a long shutter speed, and you can still get a very fast moment in time. Okay. All right, so now if you have this problem, which is called slow sync, by the way, where you have not only a flash, but also a somewhat long shutter speed, you have quite a bit to combat with. So that is something certainly to keep in mind. So you absolutely must have a tripod when you're using a slow sync. And realize, though, that when you're using flash, part of the reason that it's appealing is that we can illuminate objects in the room without needing a tripod to begin with, because it enhances the amount of light that exists there. But what we are talking about here are more advanced techniques, reasons why you might need a tripod when using a flash, and that is for using, as always, very, very long shutter speeds that happen.